Hello, we have here circle B, and we are asked to solve the unknown measurements of variables x, y, and z. In order for us to solve this, we also need to determine what are these variables representing so that we could come up with relationships in forms of equations that will help us solve the variables later. We need to understand that the given measurement for x, or rather the given figure that represented by x, is this arc here from this point to this point here. Y is an angle formed inside, but the angle is neither central angle nor inscribed, because for this to be considered as a central angle, the vertex must be located in the center of the circle B, and that the sides should be what we call as radii. This is also not inscribed, since for an inscribed angle to exist, the vertex of that angle should be any points on the circle, and the sides should be chords. And for final unknown measurement, z, this is represented by this arc here. So let's start with solving the value of x. And actually, you could also solve the value of y. So let's start with y. It doesn't necessarily mean that we start with x. So let's start with y. We can solve y easily by looking into consideration the relationship of this angle here and the given angle measurement of 100 degrees. These two angles form what we call as a linear pair. And if two angles form a linear pair, that would mean that the sum of the measurements is equal to 180 degrees. That's according to linear pair postulate, which tells us that angles forming a linear pair are supplementary. So that would mean that the measurement of angle y plus this 100 degrees must be equal to 180 degrees for them to be called supplementary. And since we have this value, we can solve here that the measurement of angle y be 180 degrees less 100 degrees. That would give us the measurement of angle y to be equal to just 80 degrees. This is the value for the angle y here. Now, we started with this because in solving x and z, we are just going to use the same concept. And that concept pertains to angles that are formed by chords, but not diameter. So these two are chords. And we have here two intersecting chords. We have 1, 2, 3, 4 angles, which involves the measurement of y and the given measurement of 100 degrees. If two angles are formed by intersecting chords, it is stated that the measurement of that angle is equal to the average of its intercepted arc. So if we're going to have 100 degrees, this 100 degrees is actually equal to the average of its intercepted arc, which is x, and the arc which is also intercepted by its vertical angle, meaning this one here, because this is the vertical angle of an angle which measures 100 degrees. If we don't like what average means, it just simply the sum of getting the sum of the two arcs and divide them by 2. So let us try to look into that when we talk about x. So again, this 100 degrees, okay, is equal to the average of its intercepted arc, which is labeled as x here, and the intercepted arc of its vertical angle. This is the vertical angle of 100 degrees, and its intercepted arc measures 65 degrees. So this is the equation that can be used to solve for x. Let me increase this portion here for more computation. So we could use this to solve for x, bearing in mind that it's not the angle that is unknown, but it's one of the arcs. So we multiply both sides, you will get 200 degrees is equal to x plus 65 degrees. Because as you multiply to both sides, this will be removed. Therefore, we could solve x here by using subtraction property or equality and symmetric property. Therefore, x is the difference of 200 degrees and 65 degrees. In short, the value of x here is given to be 135 degrees. So this is now the value. So if we're going to look into consideration again the definition of angles formed by chords, and let's say it's 100 that we don't know and we are sure for x to be 135. So 65 degrees plus 135 degrees is 200 degrees, and half of it should be the measurement of this angle, and that half of 200 is 100 degrees. This is the value of the x. Now in solving for z, we could apply two different methods. One of the methods that we could apply is looking into the circumference of the circle. The circumference of the circle is equal to 360 degrees. And since we already have 65 here, 78 here, and the newly solved x, which is 135, we can solve z for that. So let me move first this portion here. Okay, move this a little bit closer here. Okay, really erase this one. So we could solve z here. So it should be stated, or it should be in this manner: z plus the 65 degrees plus the 78 degrees plus x, which is already 135 degrees, must be equal to the entire circumference of 360 degrees. So moving forward, if we're going to sum this up, 65 and 135 is 200 plus 78, so you will have z, and that's z, plus 278 degrees is equal to 360 degrees. And by the use of subtraction property of equality, you will get a value for z, which is actually this arc, to be equal to 360 minus 278, which is, if I'm correct, is equal to 82 degrees. This is the value of z using the concept of circumference here. I mentioned there are two methods in solving z. One of the methods is similar to process in solving x earlier, since we already have the value of y here, and we have the arc from this portion. Y is already 80, so it should follow this one here, that 80 for y, 80 degrees is equal to 1/2 the value of its intercepted arc, 78, plus the value of z here, to which what we don't know yet. This is another way of checking that. So that's 78 degrees plus z. Okay. So if we're going to multiply to both sides, you will have 160 degrees is equal to 78 degrees plus z. And subtraction property of equality together with symmetric property, this is 160 minus 78, and you will get still a result of 82 degrees. So we have now solved the three unknown measurements here in circle B using the concept of angles formed by intersecting chords, linear pair, and the concept of entire circumference.